Okay, this is conversions. Let's call it unit conversions. What's the other name for these? Physical science time. What's the other name for these? Dimensional analysis or dimensional analysis. We're going to call this part 2. The first thing we're going to do is I'm going to try my hardest to think of the ones that I need you to memorize. Okay, so we're going to have a little box over here of conversion factors to memorize. I would say, to me, or at least in this class, the most important one is that you memorize that 1 inch is equal to 2.54 centimeters. That has to be memorized. Memorized means have it in your memory. You're not going to be given this on the test, so you need to have it memorized. Memorize that 1 inch is 2.54 centimeters. These prefixes you need to have memorized. Centi, kilo, milli. That might be it at this stage. Let's remind ourselves what they are. What's the prefix centi mean? No. No. Try harder. 1/100th, yeah. What's kilo mean?
1/1.
Okay, Taylor, but if you don't know it, don't just shout it, okay? And then what's milli mean?
1/1,000,000.
No. Just thousandth. 1/1000th. Why did I not say centimeter like some of these cowboys wanted me to say? Because centi can be on any SI unit can have the prefix centi. So we talk about centimeter a lot, but there's also such a thing as a centiliter, which would be how much of a liter, if you had to guess? Of a liter. What if we had a kiloliter? 1,000 liters. We just shove these prefixes on the front, and that tells us what the conversion factor is.
So a milliliter is 1,000.
Yep, exactly right. There are more. There are things like mega and giga, and those are 1 million times and 1 billion times. I'm just going to put those on here too. Those don't come up probably in the conversions as much, but they are useful prefixes to know. We did talk about all these before when we talked about the SI in general. Now back to the other conversion factors you need to memorize. I think a useful one is 1 meter equals 3.28 feet. And this is not something we want to really get into, but this, you can only use this value when your given has 3 or fewer what we call significant figures. So, and what I mean by that is that this number is not as precise. It's not exactly 3.28. This one is pretty close to exactly 2.54 centimeters in 1 inch. This one I prefer, if you can. We'll talk about some examples of this today, but this one's a nice little shortcut if you are able to use it. If you have a very precise number, how do we know if a number is precise? Remind yourselves from the lab. How do you know if it's precise?
How many decimals?
Yeah, this number is very precise. This number is not. This number has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This has 10 digits of precision, what we call significant figures. This one only has 2. Does that make sense? This tells me that whoever measured this measured to the whatever this is, millionth or whatever, might be 100 millionth place, and found that it was this. Whereas this person only measured to the ones place. Anyway, back over here. So if we have a number that's only precise to 3 digits, we can use this, and this is a nice little shortcut. Same thing with this. 1 kilometer equals 1.61 miles. That's a nice. I'm going to put some more on here just because you really should have these memorized in your life, but I'm going to put them on here in case you've never been alive. 60 seconds equals 1 minute. 60 minutes equals 1 hour. And 365 days equals 1 year. It's actually 365.25 days, but we don't really talk about that much. You knew these, I hope, from 2nd grade, or like being a human being who has to know how many minutes are in an hour, etc. You knew these, right? I'm not going to ask you because it's going to make you disappointed, but you do need to have it memorized. Okay. Let's talk about the next method that we use in conversions. And I think I might have made this up, but I call this one chaining. This is this one is if you want to use units for which there either isn't a direct conversion or you don't know the direct conversion. So we have to have these memorized, you know? Yeah, because I just told you to. So you have to have these memorized. But what if I said, how many, let's say that fate, where's fate? Fate let's say that fate is 127. That's too short. We'll say that fate is 151 centimeters tall, and we want to find out how many feet that is. Feet, fate. Okay? No, we're all going to do it together. What's the conversion from centimeters? How many centimeters are in a foot? No, that's how many centimeters are in an inch. You're all making something up because you don't know. It's roughly 30, but you don't know, and we don't have that conversion memorized. You won't be given it on the test, so what do? What if you don't know the exact conversion? Well, what we do is we have 151 centimeters, and we go from centimeters to inches, and then to feet. We do it the same way. We've just we've chained two conversions together. A possible way to do this, a gas station way to do this, a gas station dumpster way to do this, is to solve centimeters to inches, write down the answer, and then convert that number of inches to feet, and write down that answer, and that's the final answer. I don't like that, because that reduces precision using all the decimal places you could. Please do it like this. Chain it. Now, once we have our units written, how many, say to yourself, inches are in a centimeter, or the other way around? How many centimeters in an inch? 2.54 centimeters in an inch. How many inches in a foot? 12 inches in 1 foot. Multiply by everything on the top, 151 times 1 times 1. Now here, this is extremely important. I'm going to show you on your calculator. This is true for any calculator that I've ever experienced. You type in 151. You know how to use calculators. 151 times, well, you don't have to do you could put in times 1, but you're familiar enough with algebra to know this is just going to give you 151, right? Yeah. Okay, so then you divide by 2.54. You have to press enter between the divisions. So divide by 2.54, enter. Divide by 12, enter. If you don't, what it does is divides 2.54 by 12, and then divides this by that, and that's going to be worse. Actually, it's going to be wrong. It's not worse, it's just wrong. The answer is 4.95. 4.95 feet. This says you're about 4'11". Is that true, Fate? Dang. Well, this is not Fate. Who is 4'11"? Kyla. This is Kyla's. Okay. Okay, let me go over the chaining again, though. Why do we want to do this? Well, the reason we do chaining at all is because we don't have a direct conversion from centimeters to feet. Here's what tricks people. No, not tricks people. Here's what people get tripped up on this. What do I use here? What if we used 151 centimeters and we went and said, think of another way we could do this. What other two conversions could we chain together? Centimeters to, using just the stuff we know. Yep, centimeters to meters, and then meters to feet. Let's see if we get the same answer. In 1 meter, there are 100 centimeters, and in 1 meter, there are 3.28 feet, about. This time, we take 151 divided by 100, enter, times 3.28 equals 4.95 feet. It's the same dang answer. We just have two different ways to get there. So is there a right way to do these chaining ones? Well, I mean, there's certainly a wrong way, but there's not necessarily one right way to do them. You can take many different paths to get to the same place. Just like if you're going from here to Westco, you can cut across the football field, you can go around the track, you can go over by where the dead bus is. There's a lot of different ways to get to Westco. There's a lot of different ways to get from centimeters to feet. These are just two examples. To make it more clear, the part people struggle with is what units do I use? Because this unit here, it doesn't say centimeters to meters to feet or centimeters to inches to feet. You have to figure out this intermediate unit yourself. Do you think you'd be capable of doing that? Usually it should be pretty straightforward. You should be able to think, oh, I can't get right to X, I need to go to Y first. It should be pretty clear. If you're having a hard time with this, especially while you're doing your worksheets, let me know and I will help you. Some of them get pretty dang long. One of them is convert 17 years to minutes. So you have to go, you don't know how many minutes are in a year.
Yeah, I do.
Yeah, he does because he knows about musicals. But if you didn't know that, which Hunter's not going to start singing, this is not High School Musical, but if you don't know this song, you can convert from years to days, days to hours, hours to minutes. There's your answer. You just have to be able to go down the line. Do you have questions about chaining? Instead of doing practice ones with these first, I'm going to illustrate the other two techniques that we need to have, and then we will go on to practice afterward, after the video. I don't have a yard up here anywhere. How many? This is a year. Year. 3.65. 365.25 days are in a year. Okay, the next one is rate conversion. Please pay attention. Please write this down. Rate conversions. I'm going to do that in cursive too, like I had the other one. Rate conversion. What's a rate? We had talked about this yesterday. Yeah. It's. I would. It doesn't have to be an average. It doesn't have to be an average. What it is, listen, please.
Where this whole number is the denominator.
Not always. Okay, but you're getting at something that's right. It is always can be expressed as a fraction because it's comparing two units. So things like miles per hour. What does that measure?
How many miles you go every hour?
What do we call that in physics?
Miles for every hour.
What is the quantity we're measuring by miles per hour? Say it. No.
Velocity.
Speed or velocity. So miles per hour, that's how your distance, miles, compared to the time it took, hour, and that's speed. So an example of a rate. Remember in boys' toilet, there's a urinal that has gallons per flush on it? That's for every flush, it uses this many gallons. Because comparing gallons and flushes, which flush is not a real unit. But so when we do rate ones, for instance, let's say Taylor Homan is moving at 3.4 meters per second on the football field. Meters per second. 3.4 meters per second. And we want to find out how many miles per hour. Let's take just a brief moment. What's the abbreviation for miles, as you can see that I've written here and down here? MI. Here's a little tidbit. MI is miles. MIN is minutes. You need to write this down. What's just M? What's lowercase m? Meters. If you are mixing these up, if you abbreviate minutes as MI or miles as M, you get it wrong. These are the wrong, or these are the right ones. But if you switch these up, they're wrong. You can't just pick your own abbreviations. We, human beings who talk about this and know things, agree that these are the units that we use. These are the abbreviations that we use for these units. So you can't just come in with your big girl pants on and say, oh, I'm going to abbreviate minutes as M, because that doesn't work, because everyone else says that meters are M. So you can't do that. You need to make sure you use these correctly. Anyway, we're going from meters per second to miles per hour. 3.4. Yeah, okay, there we go. So how many meters are in a mile? Do you know? No. So we need to chain this first part. What can we do?
We can go meters to feet.
Okay, we can go meters to feet, and then, Gabe, no, someone else who isn't Gabe, and then,
Do we have any feet in a mile?
yep, feet in a mile. Good, so I hope you're writing this down. And then, okay, but wait, it was meters over 1 second. Do you see that? There's no 1 here, but you know that that's the same, right? This is 3.4 meters divided by 1 second. That makes sense so far? Now remind yourself from what were the rules yesterday? If I want to get rid of seconds, what's the actual rule to reduce this unit seconds to 0? In all these other ones, we just put it on the bottom. What's the actual rule, though? Is it just put it on the bottom to get rid of it? Well, there are only 2, so it's either bottom or top. But how do I know? What's the actual rule? Go back in your rules. You wrote this down. What is the actual rule to reduce the unit to 1? No, not always.
Input units, so they reduce to 1, or put desired units on the same side of 1.
Yeah, not or put desired units on the same side you want them to be. Where do you put the units you want to get rid of? I still haven't had my questions answered.
The bottom.
No, not always the bottom. What does it say? What does it say in your rules? For this one, it's the bottom. For meters, it's the bottom. Because on the opposite side. To get it to reduce to 1, we put on the opposite side. So where should seconds go to reduce seconds out? Someone's not paying attention. I don't know why. You need to pay attention. Yeah, to get rid of seconds, we put it on the top. What do we want on the bottom then? What do we want on the same side as where it's going to be? No, not necessarily. We wouldn't have to do that. Do you know how many? There's 60 seconds in a minute and 60 minutes an hour. How many seconds are an hour? We can do that.
360.
3,600. Okay, so now we go through and fill them all in. Remember, we have this over here. In 1 meter, there are 3.28 feet. About But see, we only have 2 units of precision here, so we can use this one that has 3 because that's more. In 1 mile, there are 5,280 feet exactly, and in 1 hour, there are 3,600 seconds. You definitely could do this as 1 hour to 60 minutes, and then 60 minutes to, 60 seconds to 1 minute. That would definitely be a possibility, but this is going to save us some space. You might as well have this number memorized. That's how many seconds are in an hour. Now we multiply by everything on the top, divide by everything on the bottom. So what I'm going to type in my calculator is 3.4 times 3.28 times 3,600. How come I can skip the 1, remind me? It's the same dang thing. And then enter, divided by 5,280, enter. I get 7.6, well, let's check it out. 7.6 what? Well, meters reduced to 1, feet reduced to 1, miles are left on top, seconds reduced to 1, hours is left on the bottom. So what's my unit? Miles over hour, which we pronounce as miles per hour. Last step, does this make sense? Would it make sense for someone to be able to run 7.6 miles per hour?
Yes.
Yeah, it's not particularly fast. Maybe he's not sprinting, but this is a reasonable speed, so you check it for reasonability. Yeah, it should have been Gunner in the example. Great job. Great job, Taylor. Now you've bullied someone. Okay. Do you have questions about the rate ones? What's the key takeaway from rate? Hey, stop talking and answer my question. What's the key takeaway from the rate one? Remember, a rate is a unit that has units in the numerator and the denominator. What's the key takeaway from this? What was special about this one? To eliminate the unit in the denominator. Yes, we did have a lot of change, but that's not what's important about the rate one. What is important about the rate one? What makes it special? Remember, it's a unit divided by another unit. So what was special about the way we solve rate conversions? To get rid of the unit, I'm going to tell you. So write this down somewhere, because I can't believe you weren't paying attention. To eliminate, let's not say eliminate, to reduce the unit in the denominator, put it in the numerator. So even though usually to eliminate a unit we put it in the denominator, in this case, since it's already in the denominator, we put it in the numerator. Someone going to say amen? Amen. Okay, thank you.
Amen.
That was obnoxious. Okay. You will do more practice on these on the worksheets. Let's start the next one. This is the one that probably won't come up very often, but we're going to do, I'm just going to do it in the corner here, exponential. What if we have, let's say we have a little piece of construction paper that is 8 by 11 inches. How many square inches is that in area? Just do it in your head. 88. Yeah, 88 square inches. So we have 88 square inches, and we want to find out how many square centimeters that is. Is someone going to pay attention to me? 88 square inches is about the area of a piece of computer paper. We want to find out how many square centimeters that is. Okay? Well, we cannot just convert right from inches to centimeters, because look what we're going to be left with algebraically. If we have inches squared times this expression, what's our current unit going to be if we solve this? Yeah, it's going to be inches times centimeters over, well, that's what it is. That's it. Inches times centimeters. Is that what we wanted? No. So what we have to do is for every exponent number, we do the same conversion that many times. So instead of just converting inches to centimeters once, we convert inches to centimeters again. So we have 2 conversions of inches to centimeters. That's going to eliminate both of these inches, and it's going to leave us with centimeters times centimeters. What's another way of expressing centimeters times centimeters? Oh, wow, and that's what we wanted, centimeters squared. Centimeters squared. But you still do the conversion. So in every 1 inch, there are 2.54 centimeters. How many centimeters are in 1 inch? 2.54 centimeters in 1 inch. 88, I type in my calculator, 88 times 2.54, enter, times 2.54. You didn't have to do the enter on that one. But I get 570 square centimeters. Does this math make sense? Well, if we had, roughly, if these were just 2, that's kind of an egregious rounding error, but if these were both 2, we'd have 2 times 2, which is 4. 88 times 4 would be about 90 times 4, that would be about 360. Is this number within the realm of reasonability? Yeah, yeah. So the 3 we went over were in chaining. In chaining, we do multiple conversions right next to each other, chain them together so that we can get our desired answer. In rates, we had to be careful that the unit in the denominator was reduced out in the numerator. And then in exponents, we have to do the conversion however many times the exponent is. Do you have questions about any of these that you want on the video? Okay, that's probably good because now we're going to have time to practice them.